Good morning, students. The topic that I will take up today is frequency of tides. In a day, we have a cycle of a high tide followed by a low tide, then again a high tide, and then again a low tide. And these occur after a difference of 6 hours and 13 minutes. Now let's talk about the first high tide at point A. Now as you can see in this diagram, this is point A. And this is a point on the surface of the earth, and let's say this is the moon, and what you see around, this is the position of the sea water. Now when the point A is directly under the moon, there will be a high tide at point A. As you can see this bulge, and exactly opposite to point A also there will be a high tide. Now this high tide is because the force of gravity of the moon is maximum at this point, so most of the water is pull towards the moon, and this high tide is a reactionary force to the centripetal force of the moon, the force of gravity of the moon, that is the centrifugal force experienced by any object on the earth due to the rotation of the earth. You see these arrows here, these arrows show the direction of rotation, that is from west to east, and the moon is also revolving around the earth in the same direction. But the speed of revolution of moon is comparatively less than that of the speed of rotation of the earth. So this is when the first high tide occurs at point A. After some time, the point A would have moved to another position. Let's say after 6 hours and 13 minutes, the position of A will change. Now let's talk about the next position of A, when after 6 hours 13 minutes the earth has rotated, and now this is the position of A. And here we can see that the moon has also moved, but compared to the earth, the speed of revolution of the moon around the earth is very less. So there is not much displacement in the position of the moon. And what do we see here? That relative to point A, now point A and point M, they are perpendicular to each other with respect to the center of the earth. So here at point A, the gravitational pull of the moon is felt the least. Hence we have a low tide here. All the water moves from A towards a point which is directly under the moon. And the same thing happens on the opposite side also. So here we have the high tide, but at point A we have a low tide. Then the next position, the moon, when the earth rotates, the position A would have moved. And let's talk about the position of A after 6 hours and 13 minutes. So now here, this is the position of A, and this is exactly opposite to the point of the earth which is directly under the moon. Hence, again there will be a high tide at point A. And again after 6 hours and 13 minutes, the position of A would have changed. And here again, from the center of the earth, the moon and point A, they are at right angles. So here the force of gravity of the moon is felt the least. Hence there is a low tide at A. So generally there is a high tide, and after 6 hours and 30 minutes there is a low tide, followed by a high tide again after 6 hours and 30 minutes, and then a low tide. Now this happens in most of the cases, but it is not necessary that every place this kind of pattern will emerge. Because tides not only depend upon the position of the moon and the sun and the rotation of the earth, but tides also depend upon another factor, that is the topography of the land, the depth of the sea, or whether it's an open sea or it's a narrow basin. Generally in open seas, one cannot make out the difference between a high tide and a low tide. There is very little difference. But if there is an estuary, or if there's a bay or a gulf or a very narrow bay, then during a high tide the water will gush in and the level of water will increase, and during a low tide enormous amount of water will recede. So the tidal range is more in case of narrow basins. Also, there may not be two high tides and two low tides in a day. There may be just a high tide and a low tide during a day, or the two high tides which occur may not be of the same level. And so is the case with the low tides. Much depends upon the topography of land. Thank you.